Right, welcome to the second session of today's events, and I'd like to thank Grey Matter for inviting me along here to speak. You've got me for this session and the session straight after lunch on a couple of different subjects. And my name's Richard Fennell. I'm the Engineering Director at Black Marble. We're a Microsoft Gold partner based up in the north of England. And I spend most of my time consulting on TFS, VSTS, Visual Studio, and in general sort of application lifecycle development, DevOps, all of that sort of area. So over lunch, if you've got any questions in those broad spaces, please grab me. What I'm going to be talking about today in this first session is how we can actually take some of the tooling that's been available to us for a while in TFS, VSTS, and in Azure, and wire them together in sort of real-world scenarios to try and deliver on this promise of DevOps that we keep hearing about in all of the various bits of the press. But the first point, switch the thing on, is everybody talks about DevOps. I don't know how many of you have DevOps in their job title or have DevOps people in your organisation. It's become fashionable. It's become, oh, we've got to have a DevOps strategy. And when you start to look back, the companies that have been successful have been doing these things all along. They've been using automation to manage build and release. They've been storing scripts in code. They don't have Word documents as their process. They try and remove human error. And that's all we're trying to do all the way along the lines. But the tooling is certainly trying to catch up and help. Now, before the break, Giles was talking about Visual Studio 2017. I will not touch Visual Studio 2017 at any point during this demo. And that's because most of the stuff I'm talking about is running as a back-end service to the developer. It's the things Visual Studio connects to. Visual Studio talks to TFS, it talks to Visual Studio Team Services, and that's the side of the product suite I'll be focusing on. Still the 2017 generation stuff. The demos I've got and the slides I'm using are a little focused around VSTS. So actually, how many of you use TFS on premises at the moment? It's quite hard to see here. Okay, how many use VSTS? I'd say that's about even, and I'd say about half the rooms maybe put their hands up. So the rest of you all use something else. And I hope none of you use nothing for source control. I've stood in this very room and done that show of hands and had somebody stand up and say, I use zip files. They've worked for me, zip files in folders. They've worked for me for years. I have never lost anything. And, well, you have to believe them when they tell you, don't you? But it's not been my experience. Anyway, DevOps. There's a lot of research kicking around now from all the various things that teams that have good sort of high-performing organisations can release faster. One of the key things is we want to move away from that we release a product once every 3 years. Visual Studio and TFS is a really good example. If you go back and have a look, and there's stuff up on Microsoft sites called their engineering stories. If you just search for Microsoft engineering stories, you'll find a pile of videos about how they've re-engineered the way they develop Visual Studio and TFS to move it from a product that ships roughly every 3 years with maybe a service pack every 18 months over to a product that ships, in the case of VSTS, every 3 weeks with new features. And those every 3 months you get a roll-up that comes out to you on-prem. And we're seeing in the change, as Giles showed, with the new installer, I don't know how many of you have used Visual Studio 2017 during the RC. It used to be when you put a release candidate on your machine, it probably wrecked your machine. But you pretty much knew you were going to have to remove that release candidate before you moved on to the next version. And in a bad case, a bit of formatting. I put the first release candidate on, and each one has subsequently just auto-updated itself. The componentization inside Visual Studio means it easily updates and just keeps itself up to date, almost like the evergreen browsers like Chrome. So we're seeing this general move, and that gives business advantage. As was said in the keynote, you know, you've got to have that business advantage, you've got to be able to play the game, and that's what these tools tend to do. And the area this is often being called out to is for DevOps to help improve your product and also improve the quality of your product. So there's been a lot of pressure to push round and make your product more secure, easier to work with, all of these areas. Now, the session I'm doing after lunch talks more about security, so I'm going to skip over that now, other than to say you can wire in a lot of security things, a bit of a teaser for later, into your automated build process. But one of the big things you'll probably see if you watch the session tonight with Visual Studio launch, Microsoft will talk a lot about left shift. And that's the stuff Jars was showing, in that you're pulling back information so it gets back to the developer sooner, like the live unit testing is a really good example. Shorten that cycle, make it faster for the dev to do stuff on their machine to pull it round. But we're also looking at, with the DevOps story, trying to produce a right shift, so to get information out in production with better telemetry and pushed back in so the developers can fix bugs faster, add new features faster, and add the right new features. I don't know how many of you have devved on a project where you've spent months writing this feature that everybody swore was going to be super important, and then no one ever used it. It's probably not happened to you. It's a very rare thing in this industry. But occasionally it does. Some people are very unlucky and it happens to them. And this is the whole thing. With better information, you can know where to focus your limited effort, because it doesn't matter what product you're working on. There is always an infinitely long backlog of things you might choose to do. And you can only do a finite set, so you want to try and do the right runs. And that's another area we're trying to enable. The whole move to the cloud as well speeds these things up. I'll be showing you as we go along that historically you needed a new server where you had to go onto your website and order it from Dell or Lenovo or HP or whoever, and you'd wait some time to arrive. Not normally that long. They're normally, a lot of the things ship virtually overnight in a lot of cases. But then it arrives, and then you get to the interesting measure, the pallet to rack time, as a friend of mine calls it. How long does it take after the server is delivered before it is actually racked, running, connected to your network, met whichever security standards are needed, etc., before you can use it? And that is a thing that is often measured in months, I've seen, especially in large corporates. The cloud sort of breaks that area. It allows us to provision stuff not instantaneously, but something that's measured in hours, not days, not weeks. We've done a large project for a big engineering company, and they were measuring stuff. At their best, they were looking at about 12 days to action a change. Now, it's just fix a typo on a page because of the provisioning test environment. And if they had to buy a new test environment, don't call it 12 days, call it 12 weeks. Because you've got to order the server, and it's got to go through all of these complex processes. We got that down to 2 hours, which means they can run things every night. They can try things every night. So DevOps means many different things to many different people, but the key ones we're going to sort of be focusing around today is we want to be able to support any platform. It's been touched on already today. Giles was talking about Visual Studio, but he showed Visual Studio for Mac. I'm not really going to use any development environments. All the stuff I'm doing is hosted in the cloud. The build agents we're using happen to be running on Windows machines in Azure, but they could equally be running on Macs or Linux boxes. If I need to build Docker, I can do that. It shouldn't matter in the DevOps process as to which tools you're using. We want to speed up the delivery for devs, so they're fast response, they're constantly getting stuff out there, and the cloud can make it faster. And that means we can move into sort of specific areas that have been written about a lot in DevOps. I don't know how many of you read the Phoenix Project by Gene Kim, or is the new one, the DevOps Handbook. It talks about these 3 areas, which is the first one, to think about your whole software development lifecycle, including release as a system, and look for the bottlenecks. It's the first step. And the tools help us do that by automation. Once we've got that, we can start to look for the feedback, find the problem areas, focus our effort. That's really important. And the one that I find most interesting, once you've got that in place, you can start to experiment. And that was the most interesting thing that came out of the big engineering project we did. We managed to re-architect a lot of the systems they were using, because historically they'd been building machines just this way, and if it takes you 12 days to build it, try and do it the same every time. When it takes 2 hours, you're far more willing to fiddle with a config file to see what else I can do. And that allowed them an easy way of moving over to move from VMs over to platform as a service and all of those sorts of areas. It's worth touching on that we always used to talk about application lifecycle management, and now we tend to talk about DevOps. There's a bit of a debate. Is DevOps a subset of application lifecycle or vice versa? It doesn't really matter in many ways. I think it's fair to say that during the ALM phase, we talked a lot about bringing product owners, testers, devs into a unified group, but we still shunned IT pros to a degree. They were the others. DevOps is all about bringing them into the game as well, and that's very much your right shift. And to help achieve that, within the Visual Studio family of products, there's all sorts of tools that we've got now. We could go into them in detail, not going to, but there's a whole range of tools. And you bring the ones that are appropriate to your organisation to bear. That won't be all of them, but it will be some of them. Always a dangerous slide, this one, asking people how DevOpsy they are. It's like asking how agile they are. I think the thing to take from this is they're all sort of in the middle-ish. Everybody's got room for improvement. And this is a journey for every one of us. Just because you have quite good DevOps now doesn't mean you can't experiment and improve it. Just because you've got nothing now doesn't mean you can't improve it. I had an interesting engagement recently. I was working at an organisation and they were saying, DevOps, we really want to do DevOps. It's going to be good. Automation, push it out, it'll be great. And we're going to push it into our integration labs, our QA labs and our staging. But when we go to production, we're always going to do that manually because it's safer. And the answer to that, historically, my answer would have been, are you insane? But actually, I've seen the light now. There's a Microsoft program manager, Donovan Brown. Some of you may have seen his sessions on Channel 9. And I was watching one of his sessions, and he said, that's fine. Just let them do it. And what you'll see is, when it fails going into production, and everybody starts complaining, you go, why didn't you find this? Well, it worked perfectly in our fully automated first 4 stages. It's just this last step where people type, where we get random shaved monkeys to type things in when they feel like it while they're doing the deployment. And that's where our problems occur. People will see through the experimentation and the practice and the systems thinking that there is an advantage. It's a show people what's possible. It's the art of the possible. So, bit of a rambling intro, but the first bit, I'm going to divide this remainder of this session into 2 halves, really. First is infrastructure as code. How many of you are using ARM templates here? That's, I can count on one hand. Maybe 2 fingers, actually. Right, ARM templates, Azure Resource Map. How many of you are using Azure? How many of you have heard of Azure? Okay. See, you can all move. Okay. When you do anything in the new Azure portal, portalazure.com, what it's using behind the scenes is Azure Resource Management templates. An Azure Resource Management template is declarative. What it does is it declares exactly what you want to build. And you might be thinking, why the hell is he going on about that? I'm a dev, or I'm a tester, or I'm a program manager. They're really important because it allows you to treat your infrastructure like you do source code. You can revision control it. That to me is the most important thing. I can take a definition, an ARM template, and I can put it in source control. And at any point in the future, I can get it out and build the infrastructure like it was today. And when I build 5 of them, they will all be identical. Because we've all had that situation where you try and build 5 servers the same, and they're all not quite the same. Just because somebody missed a tick box. Or something weird. This removes that problem. So, as it says, they're declarative, so they're text. They're idempotent, which means if I've got one and I deploy it into an empty Azure subscription, it say creates me a virtual machine. If I then run it again when the virtual machine already exists, it doesn't recreate it because it knows it's already there. But if any of the settings on the virtual machine have been changed, it resets them to back what the template is. So that stops people going and fiddling with things in production. You can keep them always the same state, which is really useful. It also means you can effectively upsize a VM. So if you've got a machine that's set to 2 cores and you need to make it 4 cores, you just redeploy the template with the template adjusted to say have 4 cores, not 2 cores, that sort of thing. You can build really complex resources. It's not just for building a single machine. You can build complete environments. So you can build a virtual network, define its network load balancers. You can drop on a VM, make it a domain controller. When that's up and running, drop another machine on, make that join the network, then install SQL, etc., etc., etc. And that's why we found it takes on average about 10 minutes to build a VM, if you're building a VM. And you often find you have to control the order of dependency that they get built because you need your domain controller up first and things like that. So we've sort of found most environments take an hour and a bit or so. When you start, they'll take a lot longer because they'll do them in series. You just do the first one, then the next one, next one, and you can get a bit of parallelization going. Also, we have noticed that the Azure infrastructure has got faster to build on recently. So there have obviously been some enhancements, and these things come down the line. As I say, you can nest them. You can do all sorts of clever things with synchronizing. So let's have a look at slides. So it's a Visual Studio template. That's all it is. You can write your ARM templates inside Visual Studio Code or Notepad or Sublime or anything. It's exactly the same as C# in the sense that if you use Visual Studio, IntelliSense will help. If you don't want to use IntelliSense, knock yourself out. They're just JSON files, so use your JSON editor of choice. But Visual Studio does actually help you a bit. So we can create a new template, and you end up with this sort of structure. You end up with is my little pointer working? Not well enough. So we end up with a JSON deploy file. That's our environment. And we also end up with a parameters file. And what do you actually get inside that JSON file? You get some JSON. And it defines a whole set of areas. Broadly, you set up some parameters that you'd like to inject into your template. The name of your environment, maybe the admin logon, maybe a password. Doesn't matter what they are. You then end up with a section called variables. And variables, as developers, you know what variables are. What you can do is concatenate parameters into useful strings as it's showing here. We want to take our name prefix and bolt it to an application and to generate unique names, that sort of thing. I said just before I start, how many months can I run on batteries that say low battery? I think I've found the answer. Forget that. Okay. So yeah, we have our JSON outlines as it's showing over there, and we also then have our resources, which are the items that we actually want to deploy. And you can pull down all these standardized resources, or you can write your own. And the final one is you have the option of outputs. The way Azure works is when you spin up a website, you might not know some detail that's going to be created. Sorry, an Azure resource, not particularly a website. So you may hit an issue like you don't know what IP address it's going to be assigned, because that's dynamic by Azure as it's being configured. So what you can actually do is you can output that out of your ARM template for use elsewhere further in your development process. So a resource is what you want to deploy. And this is the general form. You tell it what it is, you tell it which version you want. This is how you can deploy things of a specific version at some point in the future. And you give it any properties that it wants, and that's where you pass in your parameters and your variables. Yeah, your parameters are your runtime settings, as I just said. So they're the ones that allow you could deploy the same environment 5 times in parallel by giving one each an instance name, that sort of thing. And variables allow us to concatenate those. And I've already said about that. So what that allows you to do is go off, trigger that. Now you can use that ARM template triggered from your PC to deploy it. Or you could get an automated build to do it, or an automated release pipeline, or you can use it inside the Azure portal. There's lots of options, but the key is it's just code. And at that point, I will quickly show you one, because I think we're doing okay on time. So if I go in and have a look down here, that one, I have an ARM template here. I have an ARM template. Do it without IntelliSense on. We have an ARM template called Website SQL Database JSON. And as we saw before, we've got some parameters. Let's do it that way. We have some parameters that we want. We take quite a few parameters here. We don't use many variables, but you can see our template makes use of a whole pile of resources. And a template can make use of nested resources. So I could have a template that is the Richard Fennell Special Super SQL Server Spec template, and I can use that inside all of my other projects if I want to. What you can also do when you look at resources is you can set things like valid values. So when you're picking your website hosting plan, it will default to using an F1, which is the free Azure hosting plan, but I can pick any of those other values. So what I'm trying to do is make it really easy for my developer. And as I remember with this template, I have to provide 2 or 3 parameters, but all of the others just default out to values that are vaguely sensible for the developer. If I wanted to add another resource to this template, I could come in here and just start typing. That'd be fine. But what I can also do is go and just, because I'm in Visual Studio, it will launch this little wizard and it will go off and say, well, what do you want to add? Well, I'd like to add a MySQL database. And I go in and I start to type in stuff. And if I need other resources, so say if I wanted to add a network adapter, it says, oh, you can add a network adapter, but if you're going to have a network adapter, you've got to have a subnet. Do you want me to create another subnet or use one that's already in this template or another one? So everything that's going on by using Visual Studio is leading you into a sort of path of success, the pit of success. You know, it's trying to help you go through. So if you're new to ARM templates, doing it inside Visual Studio is quite good, but I'm sure like many things, once you get your head around them, you go, it's a bit heavyweight, maybe I just want to edit, it's only a JSON file, I can make that quick change in code, whatever you want to use. Lots of options there, so it really helps. So, we've got all of that, which is that one. But then, what do we need to do? We want to actually wire that and actually deploy it. So what we'd really like to do is have the ability to use that ARM template with our code. Now, we all write code, and I don't know what your processes are. If you say write an ASP.NET based website, an MVC website, or a SQL database, I don't know how you get that to production. You may have brilliant processes, but I go to many places who have, frankly, little or no processes. And it is very much the old LAWN, local area walking network, where you put it on a USB stick and you walk across and you plug it in and copy the files onto the server. We want to do better than that. We want to automate. But if we're going to automate, what we want to do is try and make sure we're always deploying the same code every time. Whether we're going to QA, integration labs, pre-production, whatever. We want to try and avoid using the older model now, where maybe you have a branch for the dev lab, and when you're happy with all your code in the dev lab, you merge that down into another branch and then push it out into the QA lab. And when you're happy with that, you merge it down into production and push that to production, because sort of you're not really testing what you've put in production. You've tested something that's a different build. We'd like to avoid that. So what we'd really like is to have a mechanism that allows us to build the product only once and then deploy it to all of those stages, doing appropriate transforms for any config files and settings and things that are appropriate. And we can play that game. And with ARM templates, it allows us to extend that game so we can also do it for our infrastructure. If you write your ARM template right, you can have an ARM template that for dev test labs is just a single server, a single website. But as it pushes out into production, maybe it starts to scale out or use bigger VMs or whatever. All of those things become options. And actually, I think I'll do this with slides. I won't do this with slides. I'll just show you it. It's going to be easier. So, doing okay on time. So, for this sample, I'm going to use Fabricam Fibre. Anybody? Joel's used Parts Unlimited, the new demo. Fabricam Fibre's what? 4 years? 5 years old? Maybe longer. Show me age. Fabricam Fibre is just a web-based. I click that. I don't think I did. There we are. Is a web-based call center service desk sort of sample app. And first point I'd say here is I've got it on this machine, and I've got it so when I press F5, just go into debug, it launches on the dev's machine. I think that's really important. You shouldn't have to do something dark magic to allow you to debug it as a dev or to kick up the tires as a tester. It should be easy for you to do your job. So the default settings are all set so they work locally. So it's running with IIS Express. It could be running with Docker, but this one's running with IIS Express. It's using the SQL Server instance that's built into Visual Studio, the project SQL Server instance. It's doing nothing clever. And I can click around and I can play with this and do whatever I want, and it's fully functional. Now, what I would draw your attention to is a couple of things. One in here, on this title line, it says Dev PC. I'm sitting still. I wonder why that is. So Dev PC, all that is reading some text from the web config file. I'm just using that to show that we can transform the web config file. The other thing, oh, with audio, aren't we? Can't believe it's mixing my phone. No, I was further away from it than that before. So, it's a little better. Okay, so the other thing to draw your attention to is down the bottom, a version number. Sorry, I'm hiding that from some of you. A version number. The version number, as you'll know, is set in the assembly info file. We just leave that as 1.000. And what the effect of that is, that tells me I'm running locally. This isn't an official release. This hasn't been version stamped. This hasn't been pushed anywhere. And one of the processes we have... Okay, this will be interesting. One-handed typing. It's a good job this isn't a typing-heavy demo. So, we've got a version number there, and one thing I would seriously encourage you to do is look at the oh, this is a louder mic, you see, so I can try and drown it out. I don't know if this is worse than them playing whatever the other channel was earlier. No, that's for you to judge as to which is the more irritating. So, one thing we do is we have instructed all of our testers to say if they ever see a version number 10000, Don't trust it. It's a dev trying to fool you. They've given you a dodgy release off their PC, and that is not allowed. It hasn't been through all of our quality gates. So you really want to avoid that one. So we've got a quick thing in there that allows us to run it locally, and I could play around with that. I won't bother. So then, if I have a look at my app here, what have I done special for this app to make it easier to work with? Well, the first thing that I've done is in my web config. I don't know how many of you use transforms, the web.debug.config and release.config. So when I do a release, the idea of that is it would transform in the correct settings for debug and release and whatever using an XSLT transform. We don't use those because that would require me to build the product twice, 3 times, however many of those I needed, which would be moving away from that. I build it once and retest it. Now, I'm not saying that those transforms don't have their place, but they're not my primary way of injecting values for production or for testing. I only use them for massive restructuring. A good example is we've written a lot of web services over the years, and they quite often need to use Kerberos security. But on a single dev box, you don't need Kerberos security. So that is the one place I'd use them, because it's not the difference between configuration string A and configuration string B. It's if I'm on a dev PC, I don't need this. Anywhere else I do. And I feel that's a useful thing, because anywhere I'm deploying it, I will make use of the extra blocks. So they're not a complete rule out, but they are fairly rarely used these days. What I do use is the fact that we use a MS deploy package to do our deployment. So if we right-click and we go into publish, I have an MS deploy package here. So if I look there, it is a web deploy package, and I've told it to output it. It's got a name as a zip file. But for all of the variables that it offers me, like what's my site name, let me just zoom that for you, I'm putting in a value that's tokenized. So I'm putting in underscore underscore some value. And you'll see this as a common thread going through. So I've done that for the site name. I've also done it for a database connection string. And I could publish that file out locally. I've already got one in Best Blue Peter tradition already done. So let me just open File Explorer. What that's done is it's created me that output file. So that zip has all of my code in it. But what it's also written for me is this set parameters file, which was an interesting choice of editor. There we are. So what it's also done, it's written this set parameters file for me. And so all of the values I would like to inject are exposed in a simple text file that I can alter the values. Now you may notice in here, we saw the one for site name, but we didn't see all the others. Where have they come from? One of the interesting, and I think largely missed features of MS Deploy that we make huge use of is that what we can do is you can add an extra file in an MS Deploy project called a parameters.xml file. And what that does is it allows you to pick up any other files and expose them. So we can see the top one there says we've got a value that we're going to use the tag underscore underscore location, and we're going to look in an XML file that is called, where is its entry there, web config, and we're also going to use this XPath query to actually find a specific value. And if we look in our web config, what we'll see is we have that value called location. It's got that default value we saw before, but we've exposed that. So when we do an MS deploy, it will ask us what value do you want for that field. And if I say nothing, it'll put underscore underscore location in, but that gives me a fairly easy way of trying to fix that. And you can see I've got other values. I could choose to expose any of them. I also do some other clever stuff with
connection strings. So instead of passing the connection string through as one long horrible connection string, I actually build it dynamically. I'm not going to go into that today. If you're interested in that, just go and look on my blog. There's a full detailed blog post of how I do it. The reason I do it is interesting, though. You'll be the judge of that, but I think it's quite interesting. The ALM template has parameters for the name of the database, the password, the logon name, and some other things. I don't want in my build process to have to enter those 4 parameters for the ALM template and then add a different connection string, because that gives me the potential to type things wrong. It makes more sense for me to build the connection string based on the same parameters that are being passed to the ALM template. So it's just trying to make things neater all the time. Rely on automation to help you. So that's given us now a project with a way of transforming its settings. Now, Giles touched on automated testing. Well, I already have in here some unit tests. So I've got some unit tests that I would love to run as part of my, there we are, 8 tests passed, as part of my automated build. As I call them, true unit tests. They run in memory without the need for a back-end server or a SQL box or anything. So I'd like those builds to run, but I've also got some other tests in here. I've also got some integration tests. So if I open up one of my unit tests, sorry, I should show you one. So if I look at a unit test, this is using mocking frameworks and all of those clever doohickeys to get everything working. And so that's great. They can run anywhere as a service, inside a build-based service. But I also have integration tests. So my integration tests, I didn't click the right thing there. There we are. My integration tests open a web client and call a REST API and check that we get some values. Now, I may or may not be able to run that test on my dev machine. It all depends whether I've got a web server and a database running. I can probably set it up for debugging to work, but that's not what these tests are for. These tests are for running as part of my automated release pipeline. So when I've deployed an ALM template and I've deployed my website, I can go and check that it's up and running. So they rely on the fact that I've pushed in 11 rows of data, because it basically says, how many customers have we got? Oh, we've got 11. Good, it's worked. So they're potentially fragile tests, and I have to consider, is 11 the right number? Does that mean I auto-generate data in? You may have noticed a web config setting. This is all actually working with Entity Framework, and Entity Framework has a tool that allows you to generate test data, so I'm making use of that. But these are the things we have to consider. These aren't tests that will run. They'll only run if everything's deployed correctly. So if the website's down, they'll fail. If the database isn't there, they'll fail. If I put the wrong amount of data in, they'll fail. But they'll give me a nice warm feeling that a deploy has worked. I then have, exactly as Giles showed, some Selenium tests. Well, he was showing Appium. Selenium is the web version. Appium came out of the Selenium project for rich desktop apps. And here I have some tests. Where are we? I have there we are, customer tests. So I have a customer test in there that, pretty simple. What we can see is that it goes off and it finds a particular page and then fills in a form and then tries to actually submit a new customer. I think it's a customer, isn't it? Yes, submit a new customer into the system. So we've got things that test the UI. So I have to consider those sort of like smoke tests, make sure the thing's actually running. And those tests could be as rich as you want. Now, we all know UI tests are relatively expensive to keep in sync with your code, but it all depends on your process. They are of great value, but we need to adopt this layered approach, and we want to be able to call all of these. So how do we do that? Well, luckily here we're using VSTS. So let's go and have a look at that. So everything I've done here, we can do in VSTS or TFS, with 2015 or later. So what I have, firstly, is a TFS or VSTS automated build that builds the call center app. Now, I'm using Git source control, but that's irrelevant. I could be using TFVC as well. So it gets the source code first. As you see, it gets it from itself, but it could get it from GitHub, another Git repo or Subversion. Uses NuGet restore to get the latest versions, and this is where we start to do the stuff about stamping and versions and all of those sorts of things. First thing we do is we use a custom task that goes in and version stamps every assembly info version file, every assembly info file with a specific version. So we will know every build that has gone off will have a unique version. Now, how does it do that? Well, it actually uses the build number, and we build the build number up like this. So that our build number is, we have two build variables, major and minor, which we set manually, 1.2. So we are controlling what version we're going to ship. So we are deciding we're working on 1.2 of the product. And every time we build the product, it will be given a 1.2 something something version number. The format we use is the last two letters, the last two numbers of the year and the day of the year. So today is going to be, something like 17090-ish, guessing. Can't remember. 90th day of the year. Are we that far yet? Must be somewhere round about. And then for every build on that day, we add a unique number on the end, 1, 2, 3, 4, 5. Now, in some organisations, we are going to ship version 1.3.7 of our product. I'm not certain how that works, because you're presetting the version. The way we work is we are going to ship a 1.2 version of our product. I just don't know what its version number is going to be. It's how many days there are in the sprint, when the product's ready, whatever. So we keep incrementing the 1.2 number until we ship it, and at that point we then increment either the 1 or the 2 when we start on the next version. So we always guarantee a unique number. So we do that for our assembly info versions. Now that, I should say, is a custom task. That's not baked into Visual Studio. So if you wanted to add something else to this build pipeline, you just click the add task here and you go and look for the tasks that you want. And you can go down here and they're divided up, or you can just search in alphabetical order, and you can see there's loads of them, and some of them are Windows specific, and some of them are Mac specific, and some of them are Linux specific, and some of them are cross-platform. So things like Ant will work pretty much anywhere. So you should be able to leverage, it doesn't matter what you're building, you can leverage these things in. If you can't find what you want, you can go to the marketplace. And if you go to the marketplace, there's a whole pile more tasks. Now, this is a nice little change that's coming with TFS 2017. You can now download straight from the marketplace into your on-prem TFS, assuming your on-prem TFS server can see the internet. Previously, you had to download the package you wanted to install as a V6 file, and then upload it, so it was like a two-step affair, but they've simplified that. But you see there's loads of things in here, some are free, some are not. And there's plenty of community development, so these are all the ones I've written. So you can see various different tasks I've written, and there's other people who've written many other ones. All of mine, if you're interested, are all up on GitHub as well, so you can see all the source. And again, I've done blog posts on how to write custom extensions. So if your product that you're working on requires you to do something really weird in the middle of the build process, as long as you can script it in PowerShell, batch file, or a bash script, you can make it an automated build process. It might require that you install something a bit weird on your build box, but you'd have needed that anyway. So that's really useful that you can extend that. So then we build our solution. I version the DAC packs, which is to do with SQL Server database stuff, and then run my tests. Now, I could drop in and run my tests such that it ran everything either based on a test settings file, but I actually just do it by file name. And I like to use a naming convention, so I call my test unit test, integration tests, Selenium tests, whatever. So as part of my build, I only want to run my unit tests. and then I just do some tidying up. And the one thing I always like to do as well, with the VSTS build, you need to tell it which items that have been built that you want to copy as your build output. Make an effort here to only copy what you want. Don't be tempted to just put a star.star in there, because you just store this huge folder structure of stuff, most of which you don't need. So I'm only bringing over my various tests that I want to run further on in the process, my publish file, and my DAC packs. And that's finally it, and then it publishes back up to TFS. So I've actually got this build triggered so it runs every time somebody checks in. So you can link this into your pull request, check-in, code review process if you want to, or you could get it to run every night. All of these are options. So if we look at that build, I can choose to just queue a new instance of that build, and it will go off and run. The second half of this is, and that build's going off and running, this one happens to use VSTS's hosted build agents, so it's now sitting in a queue waiting for a build box in Amsterdam. I think Amsterdam, I can't remember where this instance is running, it might be Chicago. It's waiting for a free build agent. It'll normally get one in 30 seconds, minute or so. So we just leave that. We then move on to the next step, which is to do a release of that. So we have built our product. Oh, sorry, I should have said. I also have another build in here that builds the environment, the ARM template. Now, you don't actually compile ARM templates. All you really do is copy them from A to B. So it's a far simpler template here, and actually with Visual Studio you can just, when you say and build this for an ARM template, it just drops it into another folder. So that does what I want. But the key is it's just copying the files, so I have a version stamped version of my ARM template and my code. Now I could have put them all in one build solution, and that might be perfect for you. The Docker sample's a really good idea there, that the Docker template lives with your code because the two are intrinsically linked. That could be true for your solutions. Here we've chosen to say, well, a SQL box and a web server is quite a common thing, and I maybe want to use it on many projects, so I'm going to treat that as a separate entity and revision control it separately. Horses for courses, you choose what you want. So, we then have our release template. And the release template, I'm hoping you will see, is a very, very similar beast to the build template. It uses the same build agents, so I can add the same tasks if I want to. So I could do a compile in a release, and I could do a release in a build. It's down to you as to what you want to build. But what we're doing here is I have defined two stages, one called integration and one called, let me just zoom that a little because we are quite small on there. There we are. One called integration and one called QA. Our integration lab has 11 steps in it. Our QA lab has 4. What's the difference? Well, let's have a look. Our integration lab runs automatically. Nobody approves it. We've got a whole pile of variables that are specific to our integration lab. And we've said you run the integration lab whenever someone starts a new release pipeline. If we have a look at our QA lab, we can see that it can only go into the QA lab if one of these people has approved it. It's any one of these 4 people. But it could be these 4 people in this order or any order or whatever. So you could say, to go into QA, you can only go in when the test manager wants it to come in. So he can have here's a release waiting to go into QA, and they have to approve it before it deploys into QA. So it's not like you as the QA manager are being swamped because Dev are doing 50 builds a day. If you only take 1 build a week, that's fine. You're just given a list of options. Equally, you can also set approvals for when it leaves QA. So you, as the QA manager, you can say, yes, I have approved that this build is good enough to go to the next stage. And if we had, say, a production stage after QA, the IT manager could then have their approval to say that they accept it. So you can build this audited, responsible chain of how to get things into production. We have variables, again, for QA, and Trust me, they look very similar, but they are different. I'll show you that in a moment. The other one we can set is you can only go to the QA lab if it has successfully been through the integration lab. And we can play around with quite complex things here. You can fan out. You could say, go to the integration lab, and if that's successful, go out to 6 labs. But then it's got to be successful in all 6 labs before you can go to production. You could do all sorts of complex stuff in there. And I said that the variables were different. If I go and click, you'd never have guessed that's a combo drop-down, would you? And look at the environment variables, you can see they are different, some of them. So many of them are the same. But effectively, these are all of the values that are required for the ARM template or the web config files. And we're storing them inside TFS, VSTS. Notice we can store them as secrets as well. So I don't need to know what the SQL password is. Someone could have typed that in. I can make use of it because I can do deploys, but I can't change it. So if you do have secrets along those lines or keys, you can manage all of that. So if we then go and look at, well, what does it actually do in our template? First thing it does is it tries to run the ARM template. So the first one is it goes out, it goes and finds our ARM template. Remember that ARM template structure that we had? There we are. ARM template, there we are. And it's in there, and there's our template. It's going to run that template. So that's got all of our config. And we then have the option, I'd sort of glossed over it, some of you may have noticed it, that with an ARM template you always have a parameters file, so you could have a text file full of the parameters that you wish to inject into the template for all the properties. I wouldn't recommend you use that, because that means you're going to be storing your secrets inside source control again. So what you have is the ability to override. So for every variable that you have, every parameter in an ARM template, I can inject a variable. So the $ brackets format just means use a build variable, a build release variable to move forwards. And I'm just passing all of those in. So I'm just injecting the values. So every time this template runs, it takes the values from this release template. I then use another custom task that injects any values into that set parameters file. Remember we had a set parameters file here? And all this little task does is it looks for things in the format __word_ format and tries to swap in any build variables. So again, I'm injecting all my web config settings. I then use the standard task that's built in to VSTS to deploy to Azure using an MS deploy package. And you see here it takes an Azure subscription as a parameter. So again, I don't need to know the usernames and passwords as someone who's going to use the Azure subscription, because that can be set up and managed centrally. So if I want to swap to use a different Azure subscription, I just pick a different one from the drop-down. And I can security trim that list as to what I should see. But if you're not using Azure, there's equivalent commands to deploy to your on-prem IIS server, or deploy to an Apache server, or deploy a Docker template, or whatever. There's all sorts of things. The key is, I'm setting up my infrastructure, I'm making sure my config values are right, and I'm deploying my website. I then use the same technique to make sure my integration tests are picking up the right URL for the test site, and I run my integration tests. I then make sure I have the right URL for my Selenium tests, and I run them. And all of these are set up, if you notice down here at the bottom, to fail and stop if there's an error. So what that means is, if all of this has worked and got to here, it must mean that my integration test passed and my Selenium test pass. So now I can throw away the environment I've just created because all of my tests have passed. So that site maybe lasts 5 minutes, 10 minutes, an hour, however, it's going to take basically as long as it takes to provision it and run your tests, which might be really quick. I can then, if it's successful, and I approve it, goes on and goes to QA, and QA runs exactly the same command, but it goes off with different settings, and this one, you note at the end, doesn't delete everything, because it's only going to update an existing working website. And you see, I'm just deploying the website. I don't bother to test in production. You might choose to have smoke tests when you deploy to production. And here, looping back, what I say is, I'd like to update my minor version number. I want to auto-increment it, so if I ever ship to production 1.2 something, it goes back and modifies my build to make sure my next build is 1.3, because I'm an idiot and I will forget to change that. And once I've shipped 1.2.997.4 to production, what the hell does 1.2.1037 mean? I'm confused. That should really be a 1.3. So that's our basic process. The one other thing I just wanted to show you is this release triggers whenever we have a successful build of the previous build. So if we go back now and have a look at all of our releases, and yeah, there we are. We can see, if we go back and have a look at builds, that was a stupid way to do it. Oh, that'll get me there in the same place. We can see that that build has successfully been running for a while, lots of successes. If I pick the one that just ran, so today is it's the 66th day of the year. Well, we all learn something, don't we? Just because February's short. We can see that my build ran. Because I just triggered it manually, I don't have associated work items or change sets. That's your traceability that you get when a dev checks things in. But I am getting that my 8 tests passed and what my code coverage is and all of those sorts of things. And we can see at the moment that it knows this build is being wired into this release. And if I go and look at this release, I can watch its progress. And we can see at the moment that it's just grabbed an agent. The agent's running, it's pulling down the tasks it needs, it's pulling down the build artifacts, and it's just got to the point where it's about to start provisioning the Azure website and the Azure database. Now, I know that takes about 10 minutes, so that's not going to finish before we've done. But we can go back and have a look at other ones that we've done. So if we go back and look at release 105, we can see we get a nice long list of successes down here. I can look at the tests, and it shows us which tests have run. And I'd like to see all tests, and we can see there's our test that ran, the integration tests and the Selenium tests. And you can see this one sitting here now saying, this is ready to go to QA. Do you want me to release it or not? And I would come in and I would go, I'd like to release that. Yes, I would. Or no, I'd like to reject it. And if I do release it, I can still set it to go off at midnight or 3 in the morning or whatever to make sure it doesn't impact your customer base. And that's the essence of all of those sort of tools bolted together. So we've already looked at those. Backup slides. So, we are in summary. So, if this has been an area that is of interest to you, and I would say probably to this audience, the bits that's new to you is probably ARM templates. And they're not super hard. They're like all dev technologies. Have horrible rabbit holes you can go down and lose things in. But what Microsoft have provided is quick start templates, which you can go up and they have templates for lots of useful things, and there's lots of community commitment to that to make those better. There's good documentation for it. There's also I glossed over it slightly, there's a really useful tool called the Azure Resource Explorer. If you're debugging, because it is code, if you're debugging the process to deploy an ARM template, they can be a bit opaque. They just go, I failed. Not the most helpful. That allows you to see far better debugging information. And there is also the Azure Manager DevOps Jumpstart, which is a program Microsoft offer that may be of interest to some of you, probably of larger organisations. Other useful links, I showed a couple of VSTS marketplace stuff. There's a link to the ones I've written, but you'll find them all in the marketplace if you search for Black Marble or Fennell. All of the code for my stuff is up on GitHub, and my colleague, who some of you may know, Rick Hepworth, who's done a lot of this work for the ARM templates. I should thank him for writing that half of this demo. All of the samples he's got for his ARM templates are up in his Git repo, and on his blog you'll find, which is on the Black Marble blog site, you'll find quite a lot of posts he's done about how to do ARM templates and how the stuff we've learned wiring them together for complex environments. So, If you find that interesting and you think we might be able to help, please don't hesitate to grab me. I'm here all over lunchtime. As I say, I'm doing a session straight after. Unfortunately, I do have to leave straight after my next session, so if you do want to grab me, lunchtime is a better time than waiting till the end of the day because I won't be here. But Amy, my colleague, who's standing at the back, and look, there's a photograph of her, so you'll be easily able to spot her. Was here all day. So if you've got any questions about the services Black Marble offer or how you think you might be able to help, and otherwise, please, I hope you found this useful and reach out on Twitter or ask questions at any point. Thank you.